Hi everyone, I'm going to do a video here about infinite limits. So let's see how it goes. It's pretty straightforward. So this is from Calculus 1, just check it out. Okay, so let's look at this. I'm going to break this down into pieces. First, we're going to sketch the graph of this function y equals 1 over x. This is what some people would consider it an elementary function that we would learn about in pre-calc, but some people didn't do that very much. It's not so clear whether everybody would have learned that. So let's just go for it here. So let me first of all give you the short answer that the graph of y equals 1 over x uh, looks like this, roughly speaking. It might be a lot better to do graph paper here, but I am not doing that apparently. So this is y equals 1 over x. And now let me break this down. One of the things we see with y equals 1 over x is that if you look at it, its domain is not all real numbers. That the function has x in the denominator, and putting in x equals 0 gives 1 over 0, which is undefined. So the function is not defined as 0, but moreover, there's vertical asymptotes, and there is a vertical asymptote, and that vertical asymptote is the line x equals 0. So let's check out what's going on here. Okay, I'm going to plot some points here. Let's make a little table, plot points here. So when x is 0, it's undefined. All right, so that was sort of, I don't even know why I wrote that there. Almost. Let's just move on then. Let's put 1 down here. Now this is y equals 1 over x is a reciprocal function. So the reciprocal of 1 is 1. And let's put 2 down here. The reciprocal of 2 is 1/2. The reciprocal of 3 is 1/3. Seems like my handwriting is not super neat today, but anyway, I'll try a little better. The reciprocal of 4 is 1/4. Now, if I make numbers closer to 0, like 1/2, the reciprocal of 1/2 is 2. Reciprocal of 1/3 is 3. Maybe let's go to 1/10. The reciprocal of 1/10 is 10. So we can see that, maybe I'll label as like this, that when x is 1, y is 1. But say when x is 1/2, y is 2, 1/3, 3, 1/4, 4. So really it just goes way up. On the other hand, the reciprocal of 2 is 1/2, 3, 1/3. So it's a pretty awesome function, and I feel like maybe I should shrink this so that I can make it more clear that there's a vertical asymptote, like so I can scale out, zoom out, one might say, to make it clear that it just really keeps going up on one side and down the other side. I didn't put in negative numbers, which are, we should put in to this. So I'm making a new little chart, but same idea. The reciprocal of -1 is -1. The reciprocal of negative 1/2 is -2. The reciprocal of -1/10 is 10, -10. All right, so we plot these points here, and they're just, oh well. You can just spend more time thinking about this. Say -4, the reciprocals, -1/4. So, yeah, that's so much fun, so interesting. Okay, now let's find these infinite limits. Infinite limits are actually not limits. So all right, so let me tell you what I mean by that. I'm saying find the infinite limit as x approaches 0 from the right. So as x approaches 0 right, I'm going to indicate what's going on by drawing these little arrows. It's really, high tech, or I don't know what do you call it. It's really something. So I draw these arrows. This is to the right of x equals 0 over here. But I'm getting closer and closer to 0. X gets closer to 0. What happens to y equals 1 over x? It's not approaching a number. It's not approaching a number, so actually the limit doesn't exist. But we have this special thing by itself, which is an infinite limit. And the infinite limit is, what are we going to write down? Infinity. Infinity is not a number. It is an indication. It's a notation to show that this graph goes up and up. In other words, y can be as large as we want it to be by making x close to 0. I mean, how can I make y as large as I want? What if I wanted, y to be, let's see, I'm writing on the paper here, back to this little thing over here, 10,000, or let's make it 10 million. How can I make, it's pretty simple to see, to make y 10 million, I just make x 1 over 10 million. So I certainly can make y as large as I want by making x close to 0. So that's what we mean by infinity. On the other hand, the next problem is x approaches 0 from the left. Okay, so what's going on here? This is the left of x equals 0, and I'm just going to draw little, these arrows. So I'm going to write down negative infinity. Maybe I should use the proper pen to make sure it shows up. Now, if the next one is sort of misleading here, find the infinite limit. Trick question, there is no infinite limit as if I come from both sides. So what the problem, Roman numeral, lowercase I, is saying 1 over x is x approaches 0 from the right. It keeps going up, that's infinity. From the left, negative infinity. But from both sides, when it says x equals 0, that means both right and left. It doesn't exist because the right is infinity and the left is negative infinity. I mean, in all cases, the actual limit doesn't exist. You know what I sort of wish I had written down here is number 4, state any vertical asymptotes. So where's the vertical asymptote? And the answer is not 0, it's the line, it's the vertical line, x equals 0. All vertical lines, whether it's an asymptote or not, are written in the form x equals a number. That's just how it goes. Okay, so this, that does it. You can always click like and subscribe, it really doesn't matter. This is all free, no money involved. This is not a super awesome video, but it's just, I'm trying, but not that hard. I mean, anyway. So this is just free math videos for students, etc. Someone's making money, YouTube a little bit, because apparently there's a bunch of advertisements on there. Okay, so anyway, I guess I'm done, and it'd be awesome if I could end with a joke, like a real clean, fun joke. And why did the chicken cross the road to get to the other side? Along those lines. Okay. Hey, take care. Take care. All right. Bye.